Hi there. The last video you saw was about multiplying exponents to the same base, and today we're going to be talking about dividing exponents to the same base. A lot of what we're going to be doing is very similar, and hopefully you should notice some of the things that are the same between the last video and what we're about to talk about. As you should remember, whenever we're dividing, this is actually another way of writing a fraction. And so all of the problems we're doing today will be written as fractions. And if we see here, we have 3 to the 5th and 3 to the 7th. And if I write everything out, I have 5 3's on the top of my fraction, and I have 7 3's on the bottom of my fraction. Well, you know that any number divided by itself is just 1. So that essentially means that we can cross out one pair of 3's from top and bottom. So I can cross out these two right there, and I can continue going down the line and crossing out pairs. So all I'm left with are these two 3's down here at the bottom. I've got 3 times 3 on the bottom of my fraction, and since there's nothing in the top, I need to put a 1 up there. Well, you should remember that 3 times 3 is 3 squared, because 3 to the first power times 3 to the first power, since they have the same base, you add the powers together, 1 plus 1 is 2. Now, this seems like a lot of work for just one simple problem, but there's a faster way of going through this. If you notice, 7 minus 5 gives us 2. And the way that we want to do this is to simply subtract our powers whenever we're dividing. The shortcut for this problem would be, since the larger power is on bottom, that's where we're going to put our 3. So since we have a base of 3 and the larger power is on bottom, we're going to start by putting a 3 on the bottom, and then we simply subtract 7 minus 5. 7 minus 5 gives us 2, and so we put a 2 here. I'll go through this next example using the shortcut method rather than writing everything out. So here I have 6 to the 8th power over 6 to the 3rd. And what I'm going to do is I'm going to write out a new fraction, and I'm going to put my base of 6 wherever it has the largest power. So for instance, here I've got 6 to the 8th power in the numerator, so since that's the larger power, I'm going to put a 6 in the numerator of my new fraction. Just like that. And then I am going to have 8 minus 3 as my power. Now, we see that there's nothing down here on the bottom, so since there's nothing down there, we need to put a 1. And 8 minus 3 gives us 5, and so we end up with 6 to the 5th power. We don't need to write the over 1 anymore, because we know that anything divided by 1 is simply what we have, so I'm just going to write 6 to the 5th power for my final answer. So as you can see here, some of our answers will end up as fractions, some of them will end up as just numbers that aren't in fraction form. But the thing to remember is that this time, when we're dividing, we're going to be subtracting powers instead of adding powers. And if you can follow that, then hopefully these next examples should be pretty straightforward. As usual, if you think you can solve these examples before me, go ahead and pause the video and go through these examples yourself. So for the first example up here, I'm going to write out my new fraction. And since my larger power is in the denominator, I'm going to go ahead and write my base in the denominator, so I'm going to have negative 2 in parentheses. Then I'm going to subtract 15 minus 12. Well, 15 minus 12 gives me positive 3, so I'm going to have a positive 3 as my power outside the parentheses. And as usual, if there's nothing left in the numerator, we need to put a 1 up there. So this is it. This is my answer. You can evaluate this out if you want to take negative 2 to the third power. That would give you negative 1/8 as your final answer. But you can leave your answer like this if you like. And most of the time, you will be required to leave your answer in exponential form. All right, my second example here, I've got a base of 14, and in the numerator I have 14 to the 10th power, and in the denominator I have 14 to the 6th power. So I'm going to go ahead and write my new fraction. And since 14 to the 10th power is in the numerator, I'm going to write my base of 14 in the numerator. And then I'm going to subtract 10 minus 6. Well, that gives me 4. And I'm going to have a 1 in the denominator since there was nothing left there. Once again, I can simplify by simply removing the one that's in the denominator, because if you divide by 1, you end up with the numerator as your result. So 14 to the 4th power is my final answer for this problem. The last one, we have 103 to the 7th power over 103. And if you remember from the last video, I said that anytime we have a number where there is no power shown, then that counts as being a power of 1. So I have 103 to the 1st power on the bottom. We continue this problem the same way as the others, so we have our fraction. And I'm going to write my 103, my base, in the numerator because the power is greater in the numerator for my original problem. I'm going to go ahead and subtract 7 minus 1. That'll give me 6. And I put my 1 in the denominator. Once again, we're going to simplify, and we're going to get 103 to the 6th power for our final answer. Okay, now we have some problems that have variables in them. The variables are worked the same way as the numbers that we were doing before. And you should see that these are similar to the problems that we did on the last video when we were multiplying rather than dividing. So for starters, the 5 over 3, since those are different numbers, those are different bases, we're just going to leave those alone. So let's start out by writing our new fraction. The 5 and the 3 are going to stay exactly where they are. They're not going to change at all. Now the x's, I have x to the 6th in the numerator and x to the 3rd in the denominator. So I'm going to go ahead and I'm going to put a base of x in my numerator because that's where the power of x is the largest. And then I'm going to subtract 6 minus 3. Well, 6 minus 3 is 3, so my power of x is going to be 3. Then for my y variables, I have y squared over y to the 7th. Well, the power of y is larger in the bottom, so I'm going to write my base of y in the denominator. Then I will subtract 7 minus 2, which gives me a power of 5. So this is my final answer. We don't have to do any other simplification because there are no numbers that divide both 5 and 3. So my final answer is 5x to the 3rd over 3y to the 5th. With my second example down here, now I have numbers with the same base. So I'm going to work these the same way that I was working the numbers in the previous problems. So let's write out our new fraction. and we'll see that our base of 6, is going to be in the numerator because our power is larger in the numerator. So we've got a base of 6 in our numerator, and 8 minus 2 gives us 6. So now I have 6 to the power of 6. With the a's, we have a to the 5th over a to the 0. Well, 5 is bigger than 0, so we know that our a is going to go in the numerator. And 5 minus 0 is simply just 5, so I have a to the 5th in the numerator. With the b's, we have -3 and +4. Well, positive number is going to be bigger than a negative number, so I'm going to have 4 minus -3 for my power of b. So let's write our b in the denominator. And I'm going to actually write this out because this one, since it involves a negative, is going to be a little different. So I'm going to have 4 minus -3. And as you should remember, anytime we're subtracting a negative, that becomes a plus. So this is basically 4 plus 3 now in the denominator. So I'm actually going to end up with b to the 7th power in my denominator. So whenever you have a negative, remember to be careful about your subtracting because the signs do change sometimes. Here are 2 more examples that we're going to go through, and we're going to work through these the same way that we were doing with the last problems. So here I have 2 bases that are the same. I have 3 and 3 to the 5th power. So let's go ahead and write out our fraction. And 3 to the 5th power is larger than just 3, so I know my base of 3 is going to be in the denominator. And if I have just a 3 from my original problem, right here, my power for this is going to be 1. So I'm going to subtract 5 minus 1, that's going to give me 4. So my answer is going to have 3 to the 4th power. With the bases of m, we see that m to the 7th is in the numerator, so we're going to want our base of m in the numerator. And then I'm going to subtract 7 minus 4, that gives me 3, so I'm going to have m to the 3rd. With the n's, I have n to the 12th and n to the 18th, so I find that I'm going to have my n base in the denominator, and I'm going to subtract 18 minus 12. And since 18 minus 12 is 6, I'm going to have n to the 6th power in the denominator. With my last example here, I have 8 over 12. Let's just write that out since those don't have the same base. I have a to the -3 and a to the +7, and since a to the +7 is bigger, I'm going to have that in the denominator. And then 7 minus -3 is the same thing as 7 plus 3, so that's going to become a to the 10th. With the b's, I have b to the 9th and b to the 14th, so I'm going to subtract 14 minus 9, that gives me 5, so I'm going to have b to the 5 in the denominator. Our last step is to simply divide both 8 and 12 by 4, which will simplify our fraction. And when I do that, I'm going to get 2 over 3.